Hey everyone, welcome back to your math class. In today's lesson, we are going to be talking about percentages. So in the last few lessons, we talked about fractions and decimals, and we went through some different problems working with fractions and decimals. So today we're going to talk about percentages. We're not going to do word problems today. I've decided that we're going to bunch together a bunch of questions involving word problems all into the same lesson. But before I get ahead of myself, let's dive into the plan for today's class. So we're going to look at the basics of percentages, what they are, when we use them, some practice problems where it's just pure math and nothing else. So we're also going to focus today, like I said, we're going to talk about percentages, but then we're going to focus on how percentages relate to decimals and fractions, because it's not always the most obvious, especially how they relate to fractions. Fractions and decimals, everybody kind of sees together. Percentages, not always taught at exactly the same time. So we're going to spend a lot of time today converting between percentages and decimals and like both directions, so percentages to decimals, decimals to percentages, and then also percentages to fractions and fractions to percentages. And I've decided we're going to leave the word problems and more complex questions for next week. So you guys will be watching this video on a Thursday. So for next Tuesday's class, we're going to go through more practice problems for fractions and decimals and percentages. So let's take a look at next week. So here's a look at what you guys can expect for next week's classes, actually for the 3 classes after this one. So the first one, Tuesday, February 6th. Hopefully I've got my dates right, but next Tuesday's class, we're going to go through practice problems. So that's going to be for fractions and decimals and percentages, and it's going to include some word problems. So probably similar to what we've done in the last few classes, where you've got some just pure practice questions followed by word problems, and then again some pure practice questions followed by word problems. We're going to do things like that. So it'll be like a slide of practice questions for fractions, and then a fractions word problem, and then some for decimals, a decimals word problem, and then same thing for percentages. And that'll be the whole class. At least that's what I'm envisioning right now. I might rethink it when I'm making that lesson over the weekend. And then I'm also going to assign some homework questions, and an answer key will be provided to your teachers. So the idea for that is, so I'm not just going to give the answer key to your teachers. It'll be with your teachers, and then I'm thinking I'll have just the final answer, not showing all your work, but just the final answer. I'll make it something that you guys can also check. So perhaps I'll put that in a video that's, just a separate video by itself, that here are the answers to the homework questions without showing any of the work. And the idea is that I want you guys to do the homework questions, and I want you to check whether you got your final answer right. And you can check that with either the resource that I make or with the answers that I give to your teachers there. And if you've made a mistake, then you can go through the detailed solution with your teachers, or you can leave me a comment or send me a message or something, and we can go through it. And the reason for that is, so that's Tuesday's class. You could probably have until Thursday to finish those questions, because on Thursday we're going to do a test review. So that's next Thursday. So that's going to be an opportunity for you to ask the teachers that are there with you about the homework questions that you got wrong, that are different from the answers that I provided. And there's going to be a video that I give as well, that hopefully it'll be a little bit shorter so that you have time to ask questions. But I'm going to go through all the topics that you need to know from fractions, decimals, and percentages. Not necessarily practice problems. We'll see how long it takes to get through the review of everything that it is you need to know. And then the Tuesday after that, we will have a test. So here's your outlook for the next few classes. So today we're talking about percentages. Next class, we're going to do a bunch of practice problems, fractions, decimals, percentages. After that, test review, and then the class after that one. Now I'm also thinking more details coming soon once I have a closer look at my schedule, but I will also try to host 1 or 2 live review sessions on YouTube. So like a live stream for half an hour or an hour. The times If I'm able to do them, I'll give the times to your teachers ahead of time so they can let you know when that'll be. Where I'll be on a YouTube live stream, and you guys can drop in, type your questions in the comments, and I'll go through them for that half hour or 1 hour or whatever. And I'll try to do 2 of them. One probably during the day, like when I've got a day off from work, so that perhaps you guys can ask while you're at school. And then one in the evening, so that when you guys are at home, if there's something last minute the night before the test, again, I'm going to have to check my schedule. I think I should be available the evening before the test, but I'm going to figure that stuff out. 1 or 2 live review sessions hopefully coming your way on YouTube, where you guys can ask me questions that you have specifically. So I think that's all the housekeeping. Now let's get into the lesson. So first things first, when do we use percentages? And of course, what are they? So percentages, let's look at the second bullet point first. So the word percent comes from, so if you break it into 2 chunks, you've got per, and then you've got cent, right? Those are your 2 chunks. So per is like when you say like miles per hour, kilometers per hour, it's that per, and then the cent means 100, like century, or cents, 100 cents in a dollar, right? So that's where percent comes from. So it's talking about things being out of 100. So percentages, just like fractions and decimals, they're used when we're talking about quantities that aren't a whole number. We're talking about, we don't have none of something, we don't have all of something, we've got something somewhere in between, some amount somewhere in between, so something between 0 and 1. So for instance, if we were to take the classic example of a pizza, now pizzas often lend themselves really nicely to fractions, but you could use decimals and percentages as well, that if you don't have no pizza, but you also don't have a whole pizza, then you could use fractions, decimals, or percentages to talk about how much pizza you do have. Now, because a percent, a number expressed as a percentage, is something that's out of 100, that's basically saying that if you've got a whole of something, like a whole pizza, percentages do not care if you've cut the pizza into 8 slices, or 12 slices, or 16 slices. Percentages pretend that the pizza has been cut into 100 slices, because that's how percentages like to divvy things up. So if you're talking about, you've got an apple, instead of cutting it into just a few slices and eating those, a percentage, if you're talking about the percentage of an apple that you have left, the percentage is insisting that you chop it into 100 bits. So as a result, 0 as a percentage obviously is going to be 0%. 0 tends to stay pretty much the same across the board, but 1 as a percentage is 100%. So if you've got 1 whole pizza, you've got 100% of a pizza. If you've got 1 whole apple, you've got 100% of an apple. If you've got a water bottle that's completely full, your bottle is 100% full, right? You got 100% capacity of your water bottle filled. So that's where, and you'll see these examples in daily life. And one of the really, really common examples, I'm sorry that the text is a little bit cut off here, but when you're looking at your grades in school, a lot of the time grades are given as a percentage. So you do a test, you get 80%, 90%, 95%, 100%, right? But the really great thing about using percentages, especially when we're talking about things like grades, is we use percentages a lot of the time when it's either impossible or it just doesn't make sense for the quantity that you're talking about, for the quantity that you are talking about to be outside this range of 0 to 1, or this range of 0% to 100%. So a good example of that is grades, where if you ignore the special circumstance of having like bonus questions on tests and exams, generally speaking, your grades won't ever be higher than 100% on a test or an exam or your grade for a class, and they'll never be below 0%, right? If you show up to class and you never do any work and you don't write any of the tests, or you get every single question wrong and you don't even try, you'll get a 0%, but you won't get anything less than that. You won't get a negative percentage, right? Now, you can sometimes see negative percentages, but that's when we're talking about how much things have changed. So if something you used to have more of something and now it's shrunk, then you can talk about that a little bit with negative percentages, but we're not going to really get into that. That's one step further than where I want to go, at least for today. But yeah, so that's where we use percentages. Now, today we're not going to really worry about the use cases for percentages. We're just going to practice working with them, do a couple questions, converting between decimals and fractions. So if we look at this, we've got this image right here. You've got this one giant square and it's been cut up into 100 little pieces. You can count them all if you want, or you can do it the easy way, which is you count going across. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And going down, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 times 10, that's going to be 100 little squares that we have in the middle. And here, these three numbers up here, this percentage, this decimal, and this fraction are all representing the amount of space in this square that's shaded in this light blue color. So if this were a fraction, we could say, well, we've broken this square into 100 even-sized pieces, equal-sized pieces, and we've colored in 43 of them. And again, you could count that out, or you can say, okay, well, we've got 4 complete rows, and then 1, 2, 3. So 4 rows of 10, that's 40, plus 3, that's 43. So we've got 43 out of 100 little squares are shaded blue. As a decimal, it's going to be, we're still talking about something that's been split into 100 pieces. So if we look at this decimal number, 0.43, remember that this 0 is in the ones place, this 4 is in the tenths place, so I'll write those in. So this is the tenths place, which is where the 4 is. This is the ones place. And then this 3 is sitting in the hundredths place, right? So that's the key here, is because we've broken the square into 100 little pieces, then when we write it out as a decimal, we're going to go down to the hundredths place. Now, of course, if we had half of one of these squares for some reason, then we'd go even further. We'd go into the thousandths place to talk about that. But in this case, we've got, basically, you could say this, if you wanted to talk about it like a decimal, you could say we've got 43 hundredths of the square are completely filled in. Or the other way you can think about it is, again, if you break it up into, we've got 4 complete rows here. Each row is 1/10 of the square. So we've got 1/10 going across here, 1/10, 1/10, and 1/10. So that's 4 tenths. So we put a 4 in the tenths place. And then we've got 3 of the individual squares, and those are hundredths. So we put 3 in the hundredths place, and you get 0.43. So there's your decimal representation. As a percentage, this is, again, it's asking how many out of 100 pieces do we have? Do we have colored in or whatever? So in this case, we're talking about how many of the squares are colored in light blue. Out of 100, it's 43. So it's 43%, because percent means out of 100. So it's 43% of the entire square. Now you'll notice that with fractions it's a little bit wonky sometimes, because, you know, if you can reduce your fraction, then the decimal, or then the denominator is not always going to be 100, and sometimes your fractions look really different from your decimals and your percentages. But decimals and percentages almost always look very, very similar to one another. So you know, if this is 43%, the decimal is going to be 0.43. and the fraction's 43 over 100, sure. But if this was 50%, then your decimal would be 0.5 or 0.50, and your fraction would be a half, right? If it was 50%, if we had 50% of the square filled in, so just the rest of that fifth row, as a fraction, sorry about my equal sign, that would be 1/2, right? So your fractions won't always look like your decimals and your percentages, and your decimals won't always look exactly like your percentages, because 50% as a decimal is 0.5, and you don't have to write in an extra 0 at the end. So it's very similar. It's not exactly the same, but it's very, very close. So when you're dealing with percentages and decimals, you'll see that they often look really similar to one another. So on the next slide, we're going to talk about how to convert between percentages and decimals and vice versa, and then percentages and fractions and vice versa. So if we are converting a number from a percentage to a decimal, all you have to do is you look at those two digits before the percent sign, and you divide by 100. So basically you're going to move the decimal point 2 spots to the left. So if it was 43%, you move the decimal 2 spots to the left. So it started out, so if you had 43%, then your decimal point was originally here because it was a whole number of a percentage. So it was like it was 43%, so 43 like 0.0%, if you will. And then you're converting it to a decimal, so you divide by 100. So you move the decimal point 2 spots to the left, and you get 0.43. And if you're converting from a decimal to a percentage, then you just go the other way. You move the decimal point 2 spots to the right. You're multiplying by 100, and you get 43, or 43.0. So that's all there is to it. For percentages to decimals, that's it. You're just moving the decimal point left and right by a couple spots, and sometimes you just got to keep track of some extra zeros lingering about. That's all there is to it. For converting percentages to fractions, it's a little bit more complicated because you have to make sure that the denominator of your fraction is 100. So actually, going from percentage to fraction is pretty easy. You take your percentage quantity, so your 43, and you make that the numerator. So 43 over something, and then because percentages are always out of 100 equal-sized pieces, your denominator is going to be 100. Now in the case of 43 over 100, you can't reduce that any further, so you'd be done here. But sometimes, like in the case of 50%, you'd say, well, okay, I had 50%, so 50 is going to be my numerator, and then 100 is going to be my denominator. But now you can reduce this. So you have to recognize that you can divide out both the numerator and denominator by 50, and you'd be left with a half. So it's a little bit harder because there's this extra step of reducing your fractions to write them in the most sort of proper way. But then going in the other direction can sometimes be complicated, because to convert a fraction to a percentage, you have to start by finding a way to get your denominator to turn into 100. And your denominator doesn't have to be something like 2, where you can multiply it really easily by 50 to get to 100. Your denominator could be 3 or 7, or some number that doesn't multiply by a nice whole number to get you all the way up to 100. So you have to find that perfect way to get your denominator to turn into 100. And then you have to do the exact same thing to the numerator, right? If you multiplied or divided your denominator by some number to get to 100, then you have to multiply or divide by that exact same number to get your numerator, to get your new numerator, and that new numerator is going to be your percentage. So in the case of, let's look at the easy example of 50 over 100, or rather, really what I wanted to do here is I'm going to get rid of that. We're looking at the case of something like 1/2, right? So 1/2, if we want to turn this 2 in the denominator into 100, we have to multiply it by 50, right? So 2 times 50 is equal to 100. So we get that down here. Sorry for my writing. And then whatever we do to the denominator, we also have to do to the numerator. So because we multiplied the denominator by 50, we also have to multiply the numerator by 50. And so we get that the new numerator is 50, because 1 times 50 is 50. And then we've got 50 over 100, which is 50%. So that's all there is to it. It can sometimes be a little bit more complicated if your denominator is not a very nice number to work with to get it up to 100, but that's the strategy. So hopefully that helps. Now we're going to look at a useful trick about percentages before I give you the practice questions. So a useful trick that'll help you sometimes. It might not help you too much in the practice questions that we do today, but it is something that I want you to know about. Now I know we keep going back to this 43%. I just want to really drill everything into your heads using the same example so that I'm not confusing you too much. But the useful trick for percentages is that a percent of b, so if you've got some percentage of something, of some other number, so some number a percent of some number b is exactly the same thing as that some number b percent of some number a. So that's a little bit weird, especially if you haven't seen like things like algebra before, where you start seeing letters in your math. So let's do an example with numbers. So basically what I'm trying to say is you're sometimes forced to deal with percentages that are a little bit difficult to calculate, especially to figure out in your head. So for instance, 43% of 50. So basically what this is asking you to do, and we'll see this more when we start actually doing problems involving percentages and not just converting them to decimals and fractions, but 43% of 50, what it's basically asking you to do is you have to turn that percentage into a decimal. So the decimal would be, you multiply that, or sorry, you divide that by 100. So you're moving the decimal point 2 spots to the left right there. So it becomes 0.43. And then generally in math, if you see this word of, it means multiplication. So 43% of 50 is asking you to do this math problem. 0.43 times 50, which is, you can do it, but it's not necessarily the easiest math question in the world to do, right? Now, this useful trick up here that's saying that you can switch the two numbers around is saying that you could instead do 50% of 43, which is maybe still a little bit of work to figure out, but it's nice that you've got 50% because that's exactly half. You can kind of think through your way to most of the answer if you've got such a nice number like 50% right here. So the idea with this, again, it's not really going to come in handy today, but it's going to come in handy at some point for you guys, that it's good to know that you can swap those two numbers around. If you've got, if you've got some really, annoying number to work with, you've got, 79% of 20, right? 20 is a much nicer number. It's a round number. It's easier to work with than 79, right? And you think, I wish it was a 20 here and a 79 there because it's easier to work with nice round numbers being the percentage. And basically what this trick is telling you is you can do that. So if you had 79% of 20, that's going to be the same thing as 20%, excuse me, 20% of 79. So that's all this is. Sometimes you'll find it easier to do your calculations by swapping the numbers. So with that, now it's time for you guys to do some practice questions. So on the slide, you've got 10 practice questions. The first 5 on the left side, these are converting percentages to decimals. So I want you guys to write your decimal answers for each of these 5. And on the right side, you've been given decimals, and I want you to write those out as a percentage. So try and remember your rules for how to convert percentages to decimals, which way you have to move the decimal point for each case. Check your notes if you're not sure, and take a few minutes, pause, and come up with your answers for those. And then you guys can check them on the next slide. So I'll give you a sec to pause, and then we'll carry on. All right, so here are the answers to your percentage to decimal conversion questions. So it's going to be exactly the same process for all of them. So what you're doing in this first example, I'll go through a couple of examples in each case. So for going from percentages to decimals, you're always moving the decimal point 2 spots to the left. Now for most of these, or for 3 of these on the left side, you can't even see the decimal point. That means it's right after the last digit. So from the 42%, you move the decimal point from right here after the 2 all the way over to left of the 4. So you get 0.42 as a decimal. For 23%, same thing. You move your decimal point from here 2 spots to the left, you get 0.23. With 12.5%, you can see the decimal point, so it's easier to figure out where it's coming from and where it's going. So you get 0.125. Now with this 2%, we're moving the decimal point 2 spots. So we start by moving it from the right side of the 2 to the left side of the 2, and then we have to move it one more spot, but there's nothing there. So we put in a 0, because 0 is nothing, right? So that's how we get this 0.02 here. A very common mistake is to say that 2% as a decimal is going to be 0.2. That's not right. 0.2 is the decimal equivalent of 20%, not 2%. So don't fall into that trap. Be very careful with what you're doing when you move the decimal point. And if you're moving it more spots than you have digits, add in a 0 to fill in the extra gap, and then that'll help you keep your numbers straight in your answer. And then same thing with this one, 0.1%, we've got to move it 2 spots. So we move it first to the left side of that 0, and then we have to move it one more spot. So the decimal point is going to end up here, and we're going to have a 0 right there. So we get 0.001 as the decimal. So it's sometimes tricky when you're dealing with really small percentages. Converting them to a decimal, it's sometimes a little hard to keep track of your zeros. So that's why I want you guys to really practice this conversion right now, because when we start applying percentages to doing problems, and we're talking about, 43% of 50, then you're going to be turning your percentages into decimals to do the multiplication problem or the division problem or whatever you're being asked to do. So I want to make sure you guys really understand this conversion in this lesson, and then in the next lesson we'll dive into more involved problems. Now on the other side, it's pretty straightforward. We're just moving the decimal point 2 spots to the right, and I don't think there are any tricks on this side. They're all pretty straightforward because you can see the decimal point in every case, and I made it a little bit easy for you. I could have just written this out as a 1 instead of 1.00, but if it was just a 1, your decimal point is right after the 1, right there, and you have to move it 2 spots to the right because you're going from decimals to percentages. So you move it 2 spots to the right where there's nothing there. So you put a 0 and a 0, and you get 100%. That's what we have here. And then the last one, fairly straightforward again. You're just moving the decimal point 2 spots to the right. So all you really have to remember with percentages and decimals is which direction you have to move the decimal point when you're going from a percentage to a decimal versus when you're going from a decimal to a percentage. So hopefully that's clear. If you guys have any questions, of course, let me know, and we can go through it in more detail. Now, your last task for today is these 9 questions. You'll notice that these first 5 are exactly the same as what you just did in your percentage to decimal conversions, but now you're being asked to convert them into fractions. So it's a little bit different this time. So yeah, for each of these 5, I want you to convert them into fractions and write the fractions in simplest terms. So reduce the fractions wherever possible, and then on the right side, turn them back into percentages. You're starting with fractions, and I'm asking you to turn them into percentages. So I'll give you a second to pause, and then when you guys are ready, you can continue on to the next slide and check your answers. So here are the answers for your percentage to fraction conversions. So let's go through some of these in a little bit more detail. So with this first example, 42%, remember going from a percentage to a fraction, you take that percentage, you make it the numerator of your fraction, and you make the denominator 100. So we've got 42 over 100. And then all you need to do is spot that both of these are even numbers, so you can divide out by 2, and you get 21 over 50. And that's good enough. For the second one, 23%, the 23 becomes your numerator, 100 just automatically becomes your denominator, and you can't reduce that any further, so you're all done. Now with this 12.5%, we don't normally like to see decimals in our fractions, so we'll still do the same first step. We'll take the 12.5 and we'll make that the numerator, and then we make the 100 the denominator, but like I just said, we don't like to see decimals in our fractions. Now you've started to mix different ways of talking about parts of a number all into the same thing. It gets very confusing. So what we're going to do is we're going to multiply through by 10. We're going to multiply the top by 10. We're going to multiply the bottom by 10. So 12.5 times 10, that's going to be 125. and 100 times 10 is going to be 1,000. And then here, now you can reduce, and sometimes it's okay if it takes you a few steps to reduce that. First you realize, oh, those are both divisible by 5, and so you divide them out by 5. And then you realize, oh, those are divisible by something else. Let me divide by that. And what you end up finding is that both of these numbers are actually divisible by 125. So 125 divided by 125 is 1, and 1,000 divided by 125 is 8. So you get 1/8. So this is 1/8 as a percentage is 12.5%. Now with 2%, we get 2 over 100. The percentage just becomes the numerator, 100 becomes the denominator, and then you divide both of them by 2. So it's just another extra step in reducing. And then this last one is similar to what we did with the 1/8, is we take the 0.1, we make it our numerator, 100 as the denominator, but we don't like seeing decimals in our fractions. So we multiply by 10 and we get 1 in the numerator, 1,000 in the denominator, and you're done. And that's how you would write that out as a fraction. Now going from percentages to fractions, the first case is pretty easy. It's 41 over 100. That's just 41% because we've got 100 as the denominator. Now, if you don't have 100 as the denominator, you've got to do the extra step to turn it into 100. So for 50 to turn it into 100, you have to multiply it by 2 to get a denominator of 100. Ooh, sorry for my writing. That 100 is going places. And then this 33 also, we'd also have to multiply that by 2 because that's what we multiplied the denominator by. So 33 times 2, that's 66. So you get 66 over 100, and that's 66%. That's what we have there. Now in this case down here, 1/20th, same thing. We have to turn that denominator into 100. So 20 times 5 is what will get us to 100. And so then whatever we do to the denominator, we also have to do to the numerator. So 1 times 5, and 1 times 5 is just 5. So we get 5 over 100. And now that we've got that fraction with a denominator of 100, you just take the numerator and that becomes your percentage, so 5%. Now this last one's a little bit tricky because it's not over 100, it's over 1,000. Now, when it's over 1,000, you can try to, probably the easiest method right now would be to try and turn this 1,000 right here into 100, which you can do by dividing it by 10. So if you take 1,000, and actually I'm going to write this on the right side because for division the order matters. So 1,000 divided by, that's not a minus sign, that's a division sign, the dots are just a little small. 1,000 divided by 10 is equal to 100. But whatever we do to the denominator, we also have to do to the numerator. So 897 divided by 10, that's going to just be moving the decimal point one spot to the left. So that gives us 89.7. Oops, 0.7, like so. And then we've got our fraction right here, right? We've got 89.7 as the numerator, and we've got 100 as the denominator, because that was the whole point of dividing by 10. And now that you've got 100 as your denominator, you just take your numerator, and that is the percentage. So you get 89.7%. So hopefully all of that makes sense. All of those questions make sense to you guys. If you have any questions, do let me know. Ask your teachers, get in touch with me somehow, and I will be happy to help you guys out. So that is everything for today's lesson. As always, if you have questions, let me know. WhatsApp, Instagram, YouTube comments, I will be checking them. I will keep you guys posted about the live review sessions before your test. It'll probably, at least one of them will be February 12th, the night before your guys' test. I'll be online for like an hour or something, hour or two, because I think I'm free that night. Yeah, and I'll be available to help you guys with any questions that you might have before the test. So keep practicing your questions. If you have keep practicing, these topics. If you have questions, let me know. But if not, I will see you all in the next video. Have a good one.